students. I am Rupali Thete from Assistant Professor from GH Raisoni College of Engineering for Applied Physics. In today's lecture, we are going to have introduction of applied physics. This applied physics is related to the engineering applications which we are going to deal in the engineering syllabus. The first one which we are going to deal is almost like the electron subatomic particles, the trajectory of the electrons which will be studied under the effect of electric field and the magnetic field. The very first which we will have is electron ballistics. The word ballistic itself will give you an idea that this ballistic is nothing but the path or a trajectory along which an electron is going to move in the field of electric effect and the magnetic effect. The very first part will be dealing with electric parallel field, then the perpendicular field, and wherein you can apply electric field through some particular angle. In all these effect, the electron is behaving differently. The very first field which we deal with is longitudinal field or the parallel electric field. This is going to allow an electron beam to move ahead. That is what you can say that it will be just like an accelerating of a particle. The second thing will be the perpendicular electric field, wherein the electron is going to travel along a perpendicular path but traversing a path which is a parabola. We need to go according to the mathematical relation and just prove y is equals to kx square. Either this is the first one for the perpendicular electric field. The second one which we will be dealing here will be parabolic path, but now the case is projectile motion, wherein the electron beam is allowed to move in a making some angle theta with the field. It makes an angle theta with the field. So, here the electron beam will be moving like this. Here this will be the negative plates, this will be the positive plate. Electron beam enters like this and comes down. The motion which we are observing over here is a parabola, and this is resembling the standard equation of parabola as ax plus bx square. This is for the electron present in an electric field. The second part which we will be dealing here is the magnetic effect. Magnetic effect is little different, wherein the magnetic field will be given by the Lorentz force QVB. Now students, what you could see here, it is not actually depending on a particular particle, but it will depend upon the velocity of a particle, the charge of a particle. The thing what you could observe over here, particle will be moving fast, then the velocity and the Lorentz force will both coming out to be same. For the first part, that is the longitudinal or the parallel magnetic field, the electron or any charged particle will not have any change in the force. The reason is FL is parallel to V, the first case, or the other one theta will be 0 or theta will be 180 degree. And as per the rule of Lorentz force, you have FL equals to QVB sin theta, which ultimately will give you the total force to be 0 in case of longitudinal magnetic field. Now the case of perpendicular magnetic field comes, wherein the perpendicular magnetic field is allowing an electron beam or a charged particle to move across a circular path. See my dear student, this will be the effect of cyclotron. The magnetic effect will be very well observed in the case of cyclotron. Cyclotron has a capacity to get electron beam or any charged particle to be accelerated. Within every half, the particle is going to gain kinetic energy, and at the same time it is going to move in a circular path. So, the principle of cyclotron is very well studied in this particular case. The third case is related to the parabolic path, just like the case of magnetic field. Here we will be dealing with the magnetic field which can be applied through some angle. When the magnetic field is applied through some angle, the motion is just helical, just like a screw. The threads which are on the screw will be moving according to the magnetic field what you could see here. Now, this complete syllabus of electron ballistics and optics will be helpful for studying of some of the electronic devices which are cathode ray tube and the cathode ray oscilloscope. Now, this CRT or the cathode ray oscilloscope, they are actually dealing with the motion of electric field. In case of electric field, motion of charged particles, motion of any electrons in the electric field as well as in the magnetic field. The effect can be combinedly observed in CRT and CRO. The next topic which we will dealing here is the interference and polarization. This effect which we have already up till now done about the interference, This time the interference concepts are a bit different, wherein the interference will be considered as the amplitude division method. We call it as amplitude division method. The previous interference pattern, what we have done was related to the division of wavefronts, like the Huygens wavefront you have done, plane wavefront, circular wavefront and lot many. Now this year we will be having this as amplitude division method. Now this amplitude division method is going to give you a different things, wherein you can see the practical application of interference in the engineering fields. The first one what we will be dealing here will be interference in thin films, then the interference in Newton's ring you could see. Those things are applicable for the industrial applications. The very first is you can find out the thickness of a thin film. At the same time, the grounding or the smoothness of a lens can be very well identified by using interference concepts. This will be acting, or sometime it is also useful to get the exact parallelness or exact thickness of a particular beam, of a particular light ray which is going to incident over there. This interference, along with this, we will be dealing with for some of the applications of interference. The one of the important application is anti-reflection coating. This anti-reflection coating, the coating which you could see on the glasses or on the goggles you could have, these type of anti-reflection coating actually protects any reflections to be there. So along with that we will be further moving across the polarization. The next topic is the polarization. This polarization concept is nowadays very much related to the LEDs and LCD displays, which are especially utilized nowadays in all the areas, and polarization is dealing especially with all these. So there will be different type of methods of polarization. There will be, we will be having different methods, at the same time some more laws, like you have Brewster's law, how to generate a polarized light. Then we have Maloo's law, how you can have the combination of different polarizers or the analyzers to be taken, and this polarizer analyzer together will give you the ray which is going to come out with a lesser intensity. The Maloo's law will explain you how the intensity is going to get reduced when it come out through successive polarizers. Later on, the next topic which is somewhat related to the atomic physics is lasers. Now the concept of laser is very well known to you. The lasers are naturally available over nowadays in all many of the aspects, but these lasers are especially done at an artificial level. Though they are occurred in a natural materials, like you have the ruby laser, aluminum oxide combination plus the chromium ions are there, but this concept or the procedure of the laser by which you can get will be bit artificial one. You have to prepare a system, and the system will be giving you a laser beam coming out of it. These lasers which we are dealing here will be helium neon laser and the ruby laser. Helium neon will be the gaseous laser and the ruby laser will be the solid state laser. Now helium neon laser will be having different method of pumping, ruby laser will be having a different method of pumping. Being a gas which is a rare media will have sparsely spaced atoms and molecules. So because of that you will have to make use of electric discharge method, wherein the gases are ionized, and now these ionization electrons start moving very fast, and which ultimately generates the energy, and this is coming out to be a laser beam. But in case of ruby laser, the ruby laser, it is a solid state laser, and this solid state laser will have some different amount of pumping methods. The reason is solids are very tightly bound, they have compact structures of atoms and molecules. So we need to have a optical pumping method. The method what we use here is called as optical pumping. This optical pumping will be consisting of a xenon flash. That flash will fall on a crystal. It will be generating the energy from there. How this happens is chromium ions are going to absorb number of wavelengths from there. Like chromium has a capacity to absorb only 2 wavelengths. Those are green colored and the blue colored. Remaining all wavelengths remain unabsorbed. So the reason is here you will require a coolant, because the whole energy will be then wasted as only 2 wavelengths are utilized of that. The next part what we deal here is the application of laser, wherein you can have many applications in the medical field, in the engineering fields, and at the same time in the military area also. These have the least divergence, highest penetration power, highest intensity, highly coherent, and the monochromaticity. So, lasers will be dealing with all these parts. The last but one the topic will be the quantum mechanics. This quantum mechanics has given a broad idea to the physics, wherein it is going to deal with the modern physics, which up till now we are dealing with the wave nature of light, like in the case of Huygens wavefront. This quantum concepts will be giving an idea of a particle nature of a light. Now, this particle nature of a light can be very well identified in a quantum mechanical concepts. The very first part which was dealt here by the Einstein's principle, and the Einstein's principle was that the energy will be given in the form of a photon, a packet, a wave packet. You can call it as E is equals to h nu. This is the amount of energy which will be carried by every light particle to move ahead. This will be the energy with which they possess, and now this amount of energy will be utilized in the form of a quanta. We will call it as a quanta. Now, this particle nature will be identified by 2 more experiments, and the experiments are Compton effect, and the another one is photoelectric effect, which we have already done in the previous classes. The photoelectric effect was the concept wherein the particles are just moving across the metal and they are catching the energy from there, whereas the Compton effect will have a graphite block wherein the particles are striking over there, they actually snatch the electron from there and the particle photon will get scattered. The Compton scattering sometime also called as. The Compton scattering is somewhat related to the particle nature, and this will be better giving you an idea wherein which is not possible for the classical physics, the old physics, that is the wave nature of light. This Compton scattering is dealing with the 2 type of wavelengths, wherein the classical physics has explained this concept with the help of a wave nature. But if you talk about a wave nature, then the electron beam or any charged particle beam which is going to fall on a particle will be coming out as a reflected ray as it is, wherein there is no change in the wavelength observed. But the case of Compton effect has given a little different idea. He was telling about the concept of Compton effect as this Compton effect will be giving you a particle nature. Now, the particle nature you can discuss about. This will give you an idea how a particle will strike, will collide with the graphite block, will be snatching the electrons from the graphite block and get scattered. Now, this effect of Compton scattering was very well explained only considering the particle nature of light. Then it moves to the de Broglie concept. De Broglie concept again has given us an idea of a wave nature and a particle nature together. Wave particle duality sometime also called as. Here the particle will be moving and it will be associated with a wave. The wave nature which is observed over here will be applied to any universe in the matter. The Bell wave, we can say that any moving matter in the universe will be associated with a wave. After de Broglie, then comes Schrodinger's, who has actually dealt with the equations of these particles. Now, when you say that the particle is moving, but if the case of subatomic particles is there, the equations are totally different than the kinematical equation which we deal with. Here this time Schrodinger was the fellow who has devised a method of particles dealing and their motion, and the regions are called as Schrodinger's equation. These equations will be having time dependent and the time independent equations. These equations had helped us one more important part of that, and which is called as quantization of energy, which is given by n square h square upon 8 ml square. This was the biggest history or the biggest important thing in the case of all the quantum concepts in the modern physics. This has given an quantization of energy where every particle will be now having a specific amount of energy. This quantization of energy has explained many of the, or unfolded actually many of the things, like the case of the atomic physics, you have semiconductor physics. Those things are very well understood by considering the atomic nature and the quantization of the light. Along with this quantization, there will be few more concepts explained by the quantum. The second one will be called as tunneling. The effect of tunneling is bit different than the concept what we have dealt in the case of the first one, that is potential barrier. This tunneling effect was somewhat related to the particle which will be crossing the barrier, and the barrier will be moving like this. Here in this particular case, what you could observe is electron beam moves ahead, and the moment it crosses the barrier, it will reduce its amplitude, and the moment it comes out, again further reduction in the amplitude will be observed. But the old physics or the classical physics gives us an idea that there is no wave which could traverse or which could move across the barrier. But the concept of quantum mechanics helped us to know how the tunneling takes place. The tunneling you could see here starts as a wave, it will enter as a wave, and at the same time, the moment it crosses the barrier, it reduces the energy, utilizes the energy, and this energy is utilized like you have V, potential energy. Total energy will be E. So, you will have E minus V will be the wave which is available after crossing the barrier. But the crossing of the barrier is the important history in case of quantum mechanics. The next part what we could deal about, this concept has also explained how there is a barrier motion observed in case of a diode. In diodes, we have p-n junction, and we assume the holes and electron can move across. These holes and electron which can move across without any forces crossing this barrier is nothing but explained by using the tunnel effect. The next atomic physics has given us an idea of all these parts and the semiconductor concepts. So, the next topic we will be dealing here is the semiconductors. Now, semiconductor has changed the complete area of electronic devices. Nowadays, almost all the electronic devices are dealing with the semiconductor devices, and which are cheaper, which are having faster average rates are faster. So, nowadays we are dealing with the semiconductor devices. These semiconductor devices will be having a combination of p-n junction diode, transistors, and lot many like that. The first part what we deal in the semiconductor diode is called as band theory of solids. Now, what is the band theory of solids? You know, students are the students in a group, suppose, are sitting over there, they form their groups like that. Similarly, when you have the atoms present in a particular material, then solids have a capacity to get them attached. They will be combined together with the forces of attraction. I will give you an example of an atom will be like this, another atom will be like this. They will be coming out at a particular distance, say r. If they come close more than that, then there will be a forces of repulsion observed in the nucleus and the electrons of each other. But whereas, if it is belonging to a particular distance, say r, then this particular distance r is responsible for giving us a complete band. What actually happens over here is, these atoms are coming close together at a particular distance. We call it as interatomic distances. Now, they will come at a particular distance. This distance is such a distance wherein the particles will be exchanged, there will be a exchange of electrons, and at the same time the bonds are formed. How the bonds are formed? There will be a merging of the levels occurred, like you have E1 level, E2 level, similarly E1 level of another atom and the E2 level of another atom. These together will combine to form, and they will give you a merged energy levels as E1, E1 dash and E2, E2 dash. So, if you have two atoms will be splitted and the two energy levels are formed. If you have three atoms, then like this. If you have n such atoms are available, then these are combining together and will be giving you a structure which is nothing but called as a band. We will be calling it as a band, which ultimately forms a band structure, and the band structure is like this. The band structure which will be found here is conduction band and the valence band. The concept of semiconductors is very well explained when you are dealing with the atomic physics. Semiconductor further deals with the atoms, and at the same time they are further dealing with p-types and n-type materials which are obtained by doping it. The dopant material which we are using over here are trivalent impurities or the pentavalent impurities. These impurities will be giving you a semiconductor which is now conducting in a better way. Then these particular p-type and n-type materials are joined to give you diodes and the transistors. These diodes and the transistors are together giving you different type of application, like diode as a rectifier, diode will be working as a switch, and transistor as a switch, and not many. The last topic what we deal in applied physics is regarding to the advanced trains. These advanced train topic will be more or less dealing with all the different parts what we have up till now done, and plus the requirements in the advanced structures, like in the advanced trains. The very first we deal with the nanotechnology, wherein the nanotechnology will be dealing with the nanomaterials, their properties, their applications, the carbon nanotubes. You have different type of carbon nanotubes available. These carbon nanotubes are further classified as, you can have the nanotube classification. These are called as C and T, and these carbon nanotube structures what we get will be having different type of natures, single walled, multi-walled, sometimes also called as chiral or zigzag. As per their application, these are especially used in hydrogen fuel cells, they are especially used in batteries. Nowadays, there will be different applications of nanomaterials available.